Hello there. In this video, I'm gonna discuss the first worksheet entitled Physical Quantities Classifications. So science uses physical quantities to describe and make sense of nature. A physical quantity is a property of matter and energy that can be measured. Physical quantities are expressed by a unit, which indicates the standard used. So it has a unit and a number which indicates how many of the standard was measured. Well, this is a bit technical and sometimes it's confusing for beginners. So let us make an example. For example, you have a mango tree. You plant a mango tree and it starts now to bear fruit. So shall we say this is your mango tree? And how do you normally describe this tree? Perhaps you will be interested in finding its height. How tall is the tree? So in that case, shall we say that your tree, when you measure it, you say, okay, our mango tree is 2 meters tall. 2 meters tall. So actually we are using physical quantities already. We just don't really know the definition. But in this example, let us try to break this down. So it says here that physical quantities are expressed by a unit. The unit here is meters. So meter is our unit, in this case this M, and the number is, the magnitude is the 2 meters. What does this mean really? Well, if you say that your standard, because when you measure this, you use a certain device. So most of the time when we measure physical quantities, we use an instrument or a device or an equipment. In this case, perhaps a meter stick or a steel tape. Shall we say we're using a meter stick, so a meter stick which is 1 meter long. And 2 meters simply means that we use it to reach this height, we need to put 2 meter sticks, okay, on top of each other. So this is the first meter stick, and you put the other meter stick above it, on top of it. So this is what it means by that. 2 meters. So 2 is twice of this standard will represent this length, 2 meters. So that is what we meant by the number. The magnitude here is 2 and the standard being used here, the unit, is meters. And it's very important that we specify when we measure physical quantities. It's very important that we specify what is the unit that we use. For example, you could also have in terms of feet or in terms of inches, like the height of a basketball player, shall we say, is 6'2", 6 foot 2 inches. But in this case, we are using meter. That's why we need to specify that we are really using meter and not feet, so that we can have a standard or agree on, and we will be accurate on our when we show our measurement. Now, physical quantities are classified as basic. So what do you mean by basic? Basic means they are actually fundamental. Fundamental in the sense that these are the quantities that are defined really by agreement on, and the rest of the quantities will just be based on this. And luckily, there are only a few fundamental quantities in physics. I mean, in science. And in mechanics, we'll be normally encountering mass, length, time, perhaps temperature, but normally this one, mass, length, and time, is the most common one. So I think mass, we're familiar with this already. The symbol is M. And possible units used, you can have kilogram, or perhaps you can have pounds. So there are, or you can have grams. So there are different units that we can use to express a certain quantity. But in SI, standard SI unit, we will be using kilogram. Okay, for example, I think I am already 70 kilogram. Okay, now length, in this case, we have our example here is length. We measure it in terms of meter. So length means the distance between 2 points. It could be height, it could be width, it could be how far are you from your hometown. That is what a quantity that we refer to as length. Time, of course, I think we're familiar with this. Now note that when we measure these things, we need a device to measure, like time. We need a clock, for example, and time, the unit could be like seconds, it could be what? It could be like minutes, it could be hour, it could be year. Temperature, it could be degree Celsius, it could be degree Fahrenheit, or it could be Kelvin. Okay, and for SI unit, system of units, our standard for time is seconds. For temperature, our standard is Kelvin. For length, our standard is meter. Okay, temperature is, of course, I think we're familiar with this. Body temperature is around 37 degrees Celsius or 100 degrees Fahrenheit. Electric current, now if we deal with like higher physics already, then you'll encounter electric current, how much current flowing per unit time. And the unit here is ampere, standard as a unit. And yeah, for example, if you're familiar with a circuit breaker or a fuse, and this fuse are rated in terms of what is the maximum electric current that can flow through it, and it will trip off to protect your appliances and your house, perhaps if there will be an overcurrent. Perhaps 10 amps fuse means if the current exceeds 10 amps, then the fuse will break and will cut off the power supply. Amount of substance, normally heavily used in chemistry, we have moles. Luminous intensity, so this 7. By the way, luminous intensity has a possible unit of candela. It's like how bright the area is. This is used perhaps, for example, a room that is conducive for learning or studying must be bright enough so that the students will not fall asleep or their eyesight will not be damaged due to the low lighting. And also this is heavily used also in poultry, like for chickens to lay eggs. They must have a certain the area must be lighted enough so to stimulate them to lay eggs. So yeah, let us try to by the way, this 7, the rest of the quantities can be derived from this. So those are now what we call derived quantities. For example, if you see a car that is moving fast, a fast moving car, so you are interested perhaps on its speed. And in that case, speed is just what? Speed is just distance, how fast is the car traveling, divided by time. So as you can see, speed can be thought of just a combination of distance, which is length, and time. So speed is a derived quantity because it is made of, or it can be broken down into length and time quantity. So let us have here the detailed example. Distance as well as height, thickness, and width are all considered basic quantities because they all measure the length or the space between 2 points. Now when we say length, we don't really mean just how long it is. It could be how far your house to your friend's house. It's a measure of how far the space between 2 points. Sa Bisaya, paod sa kalayo, okay? Area is a derived quantity because area is determined as length multiplied by width. So for example, if you buy a piece of land, perhaps, that measures like this, you have, for example, like this is a lot, and then this is like 10 meters, and this is like 20 meter. So the area that you bought is 200 square meter. Okay, so the area that you bought is 200 square meter or 200 meters square. Clearly now, this is a derived area is a derived quantity because if you look at the unit itself, it's meter squared. It is just made of a meter and a meter, meaning a length and a width or another length. So the length, which we normally call this a width, this length here, this how far is this or how long is this one, we call length. So if you multiply that, area of a rectangle, length times width is 200 square meter. So area is clearly a derived quantity. Speed, that's what we have discussed already. Distance over time is just the ratio of a length and a time quantity. Okay, hopefully we got that. And Let's try to go down to some exercises. Okay. Decide whether each quantity in the pool of words below is basic or derived. Arrange each quantity under its appropriate box. Provide an explanation why the quantity is considered as a basic or a derived quantity. Okay, so let's start here with age. So where shall we put this? Well, like how old are you? Perhaps you'll say like 17 years old. Now, is that a basic quantity or a derived quantity? So you will say, okay, it's what? It's a age here is a basic quantity. Why? Because age is really just time, right? You can even convert how old are you in terms of seconds. So yeah, and again, we need just to remember that these are the 7 basic quantity: mass, length, time, temperature, electric current, amount of substance, luminous intensity. Okay, now how about brightness? Well, brightness, how illuminated the area is, perhaps by natural light or perhaps by an artificial light source like a bulb or a fluorescent lamp. As you can see, this is under what basic quantities, because this belongs to the luminous intensity. Okay, and how about density? Well, we will also encounter later on, to those who are new to this, that density is just what? Mass over volume. How heavy is an object is per unit volume. So density is mass over volume, and clearly this will be a derived quantity because mass is a basic quantity, and we have volume, another derived quantity. So mass is a basic quantity, volume is actually length cubed. So clearly this is now a derived quantity. So density here, the reason is it's a ratio of mass and a derived quantity volume. Now we also have here volume. Okay, so should have started this first. Volume is a derived quantity actually. So when we say volume, for example, let us have here, what could be a good example? Perhaps you have a glass of water, perhaps. Okay, this is your glass, cylindrical glass, and you fill it with water like this, red. Okay, now to get the volume, the content of the glass, we can just use the formula for a volume of a cylinder. Pi r squared, the area of the base, times the height. As you can see, radius here, r, the radius of our cylinder, this is a quantity length, right? Radius, how big is this radius here, and the height, how tall is this liquid level here. Still a dimension, a quantity, which of course we know a basic quantity, length. So volume is just a combination. You multiply radius by itself, and which is length times length, and height is also length. So that's the reason why it's what it is, a derived quantity. So we have thickness here. Surely this is a basic quantity because it's simply referring to length, the distance, how thick is like a book. So that is just length. And weight, for example, weight and force are, so I'll put it here, force and weight, these are derived quantities, because later on we will learn that force, in Newton's law, force is equal to mass times acceleration. Okay, and mass is a basic quantity, acceleration is a derived, it's also in here, derived quantity. So I'll have here acceleration. It's a derived quantity because acceleration is just defined as change of speed per unit time. So change of speed or change of velocity is already a derived quantity. It involves time. So clearly these are what? A derived quantity. This also is a derived quantity. This one, weight, is just a a force due to gravity. So weight basically is a force, so it's a derived quantity. Height, clearly height is a basic quantity. And boiling point, this is length, right? Length. The reason is this is the basic quantity, length. Boiling point is just temperature. Boiling point, for example, of water is 100 degrees Celsius, okay, or 212 degree Fahrenheit, or 373.15 Kelvin. So those is just actually under the quantity temperature. Pressure is force over area. Clearly, this is a derived quantity. Okay, everything that is not under the basic quantities are derived quantity. So now, to wrap it up, in summary, physical quantities, to measure physical quantities, we need to use a device, a certain standard, or an instrument calibrated to measure that. For example, for time, normally we use a clock, a watch, or a timer. For mass, normally we use here a weighing scale. For length, we need to use a certain standard, perhaps a ruler, a meter stick, and the rest of this, okay? And it's very important that we know the units that we're using. For example, we know that when we measure the length or the height of the tree, when we say 2, we should also include 2 what? 2, is it 2 meters? Is it 2 feet? So to have a good or a meaningful physical quantity, we need to, when we measure physical quantity, we need to put in the unit used and the magnitude, okay, like in this case 2 meters. So again, we have fundamentals and we need to familiarize with this, and most of this are not commonly used, do not normally appear on problems in mechanics, but in chemistry and advanced physics, this are also used. So that's it. Thank you.